Let us explore how we can predict the ability of a passenger on Titanic to survive based on the passenger's details. So what we have made is a AI model. Not just that, it's a no code notebook, which we call as the Visbooks, Visuara's AI notebooks, in which you can actually train a model and you can try to predict if you were a Titanic passenger, whether you would have survived or not. So you click to open the project and the project starts, and it has 5 distinct sections. First is problem scoping. Problem scoping means what exactly are we trying to do in this project. In this project, basically we know that in the Titanic disaster where the ship hit iceberg, it had cracks, water entered into the Titanic, and then it eventually sunk. It broke in the middle, the ship broke in the middle, which you will see soon, and it completely sunk, and a lot of people passed away in this disaster. And but there were several interesting statistics which emerged out of this, out of the data which was collected after this event, like what kind of passengers had more chances of survival and what kind of passengers had very little chances of survival. So in this project we'll be looking at how we can analyze the data from the data set available about Titanic event. So the first, we look at data acquisition. So the Titanic data has several interesting features. It has a lot of numbers from the age of the passengers to the amount of ticket fare that each passenger paid, etc. So first let us look at how the data is acquired. So data we have acquired from a data repository in Kaggle. So this Kaggle data set is what we use for building the project. But the project itself is constructed in a very beautiful way in the form of these Visuara's AI notebooks, which are called Visbooks. So first, let us demonstrate the data a little bit in its sample by clicking the show data. So it only demonstrates like 5 rows of data. So data is arranged in a Excel sheet format where there are a bunch of rows and bunch of columns and bunch of rows. So each row corresponds to one passenger, and each column corresponds to one particular characteristic of all passengers. So first it's a passenger ID. We are just IDing a passenger in increasing order, 1, 2, 3, 4, 5, just a number. And the next is a variable called survived. Survived has 0 or 1. 0 means did not survive, 1 means survived. P class has three numbers, 1, 2 or 3. It is the class of the passenger. There were 3 different classes in which passengers were boarding in the similar to the classes in train. There is a third AC, second AC, sleeper class, etc. Similar to that. Then the name, full name, then gender, male or female, age, SIB, and CBSE is basically the number of siblings or spouses who entered into the Titanic ship along with the passenger. So here 1 means with this Mr. Owen Harris, only 1 sibling or spouse came along with them. This number is important because let's say you are traveling as a huge family of 8 members. Maybe your chances of surviving is less because you will try to rescue all of your family and maybe you will not survive in that process. So that's that. Then there is a variable called P arch. There is a ticket. This is a ticket number. Fare is the money that these people paid. So you can see that people who are in P class 1 has paid more money. In P class 3 they have paid less money. So here for P class 3 it's 7.25. Here also it's 7.95. But for P class 1 it's like 71, 53, etc. So clearly this is a higher class. And then embarked is the station from which they embark. There are 3 stations. We'll show the details, and cabin is just the number of the cabin. So now let us look at the types of the data, right? Let's look at first survival. So survival, here it describes the data type. So basically if the passenger survived or not, 1 stands for survived, 0 stands for not survived. It's like an integer. So the type of the data is integer, and the value is a binary value, 0 or 1. Then here what the value average means is, on an average the value of the entire Titanic passengers was 0.38. So which means more than half of the people actually died, because more than half of the people had value of 0. And that's actually what's told in problem scoping also. You can see that out of 2,224 people, 1,500, which is more than half of the people, did not survive. Now, coming back to the data acquisition, let us look at the P class. P class is the ticket class, as we discussed. Gender and age we know. The only thing which we did not discuss is the P arch. P arch is basically number of parents of children traveling with each passenger. So here the value can range from 0 to 6. It's an integer, basically, number of parents of children traveling with each passenger. Rest of the things also. Embarked is basically, there are 3 values: C, Q, or S. C for Cherbourg, Q for Queenstown, and S for Southampton. And it's a string, because this is like a string data. I mean, Q, C, and S are string. It's not an integer. So basically, port from which a particular passenger was embarked or boarded. So now we look at these are the different types of data. So after looking at the data, we continue, and then let's see if there is a categorical data or non-categorical data. Categorical means it's discrete. Name is not discrete. Name can be anything. But T class is discrete, survived is discrete, siblings or spouses is discrete, etc. So let's look at each of them. Passenger ID should not be encoded. So basically, discrete data, we have to encode it in a certain format, one hot encoding or any other format of encoding. But basically, whichever is not discrete, we don't have to encode. So passenger ID is not relevant. It's just a number that we assign. We don't have to encode. But some other variables we have to encode. Survived, this is actually a categorical data. It's 0 or 1. T class is categorical. It's 1, 2, or 3. Right? Name, you can see there are a bunch of names. And there is gender. Gender is categorical, male or female. Age is there. Age can have a bigger range, so it need not be encoded as category. Let's just leave it as a numerical feature. Then siblings or spouses, and there are few different range of siblings and spouses. It need not be encoded. P arch is the number of parents or children traveling with each passenger. Need not be encoded. Ticket, it's basically a non-categorical variable. It's random. Fare is also the same. Need not be encoded. It's just set of numbers. Cabin, bunch of cabins are there. Embarked is categorical because there is Southampton, Cherbourg, and Queenstown, S, C, or Q. Now in the next page of the Wizbook, we try to visualize the data, basically visualize the survival probability. So let's start. First, let us look at gender versus survival. So when we plot this, we see that survival percentage is dependent on the gender for sure. Females have a higher survival probability. Or if we plot the reverse, which is number of non-survived passengers, males usually do not survive. So that's exactly what we see here. And better chance of survival, it's for females. Correct. So you can answer the question. Then you continue. Actually, in the data visualization, we can actually visualize a few more things before continuing. Like select, let's say, embarked versus survival. So here there are 3 towns from where people embarked: Southampton, Cherbourg, or Queenstown. We can see that clearly. If you embark from C, you probably did not survive. So 55% is it's basically the survival probability. So you can see that. So it depends on the the color coding. So I think orange is survived and green is not survived, or vice versa. But basically you can see that the data is different for different towns. So here more people have died from the Cherbourg than from Queenstown. Or let us look at P class versus survival. So in P class versus survival, there are class 1, class 2, class 3. Definitely class 1 has a higher chances of survival because they have paid more, and class 3 has least chances of survival. The ticket price was the least, and probably they got the least priority. In the average survived percentage, in the third class, survival percentage was less than 25%. In first class, it was greater than 60%, and in second class, it was greater than 45%. So now let's answer the question. What can be concluded? basically higher class passengers have a higher survival chance. That's the correct answer. Now we can also visualize a few other things, for example siblings and spouses, or for example let's look at siblings and spouses. So here what it shows is um, among the survived people, if you had like one or two siblings or spouses with you, you had a higher chance of survival. Among the survived people, these are the group of people who survived more in more percentage. Whereas if you had too many people with you, if you had 8 people, you rarely survive, because this is not even shown here, because almost every single person who had so many people accompanying them died, because you can see that this pink bar is like not survived is 100. Or if you had 5 people with you, there also you pretty much nobody survived if you had 5 people along with you. If you had 4 people along with you, only 80% of people who had 4 people traveling along with them died. But if you had, let's say, 1 or 2 people with you, then your chance of survival was close to 50%. So that's a very good data. So in data visualization, you can learn so many such insights by looking at the data. Now let's look at the modeling part of it. So in modeling, the goal here is to select the features that actually determine the survival probability. Let's logically think a little bit what all parameters could determine the survival probability. The name probably does not matter, name is whatever. The ticket number does not matter. The ticket price will matter, because the higher the value of your ticket, probably the more better the preferential treatment that you receive. Maybe PRs, like whether parents and children, whether you are somebody with a parent or a children with you, probably does not matter. So we don't know the exact correlation between survival and these variables, which is why to quantify it we plot this correlation graph. So basically this shows which variables among the characteristics of a passenger determines the survival probability. So here we can see that the correlation with survival for P class, gender, fare and embarked are very high. So if P class was class 1, your survival probability is very high. If gender was female, so gender you can see is by far the highest correlating variable. So from this we can see that probably we can discard these 3: age, siblings and spouses and PRs, and we can go ahead with modeling. So in the modeling, so here you can see that by checking with the above correlation, we can test for different cases. So case 1, P class, gender and fare; P class, gender and embark; age, siblings and spouses. So let's consider the accuracy of the model using these three cases. Okay, so now in the input feature, let's select the case 1. Case 1 is first P class. I select P class. So here I am selecting the features that I should use for modeling the AI model. So P class I selected, then gender, and then fare. So these 3, this was the case 1 mentioned here. So I'm selecting those 3. Fine, I selected. So input feature is basically P class, gender and fare. Output feature is literally 0 or 1, survived or not survived. Now here I will do the test set ratio. It has a value between 0.1 to 0.3, which means if it is 0.1, 10% is for testing, 10% data is for testing, 90% is for training. So I'll actually choose something 0.2, which is probably better. And then let's see by running a model. So when I run the model here, the accuracy is 0.826, which means 82.6%. Now let me select another set of features. So instead of P class, gender and fare, I'll choose P class, gender and embark. So probably I'll have to come back, refresh the page. Yeah, P class, gender and embarked. So I select those 3 features. So P class, gender and embarked are the input features. Output feature is survived or not survived. Here also I select a 0.2 as the test train ratio. Previously the accuracy was 82.6, now it is 82.1. So accuracy is already very high because we are selecting the gender. Gender has very high correlation. P class also has very high correlation. So case 1 and case 2 are very good in terms of accuracy. Now let's load this once again. Now let's not have gender in the classification. Let's not have P class. Let's select these 3 which are least correlated: age, siblings and spouses, and P arch. That's the third case. So age, siblings and spouses, which is CBSE, and third one was P arch. So I select those three as the input features, and output feature is again survived or not survived. Let's put 0.2 as the test train ratio. Run model. You can see that the accuracy is much lower. It's 61.4%. It's actually very low accuracy, because if you are trying to predict by a coin toss, if you randomly say that, oh, this passenger going to survive or not survive, you have a 50% chance of getting something accurate. So 61% accuracy is actually very low, because you are not too far away from 50%. And that's because you selected three variables. We selected three variables: age, siblings and spouses, or P arch, as the features for predicting the survival probability of a person. So that's what we use for constructing the model. And why are these three features not very good? Because their correlation with survival is not very good. But if you select 1, 2, 3, 4, the four of these features, your probability of predicting very well is very high. So that's our model. So first, actually, let me use a good model. So I'll just train the model once again with P class, gender and fair. So that is the best model. So P class, gender and fair. With this, if I train, I'll get 82 point, and if I take 0.2, I'll get 82.6% accuracy. Okay, this is good. Now let me go to the next page. In the next page, now we are evaluating the model, meaning we trained the model on a certain set of data, and by selecting certain relevant features, P class, gender and fair. And here we are trying to evaluate the model. So first, let me add my gender, male. Category for P class, let's say I'm not willing to pay too high, neither too less, so I'll select second class. And for embark, let's say I select a random town, and I'll just enter my name, and I was just going with one other person, my age, and I submit. And with this data, the AI algorithm is predicting that I did not survive. If I was on Titanic, I would not have survived. This is because mostly because I'm a male, and also because I'm in second class. But now if I convert this to female, and if I convert this to first class, and if I keep it C, and if I keep this 0, and if I keep this maybe 25, so now I'm a female traveling in first class from a town where people typically survive. Most likely I will survive. So yes, so when I click submit, when I try to predict my survival probability, it shows that I survived. I would have survived if I were a female, if I were traveling in first class, and if I were traveling pretty much alone or with just one person. So this is really beautiful. This is a beautiful way of building a model and actually predicting your survival probability. So do try this out. You will learn a lot about how AI models are constructed, how you need to pay attention to the features while building a model, because if you don't select the correct features, you will not get the accuracy that you are expecting. So try this out. Learn basics of AI model prediction using decision tree, using this book. Thank you so much.